Hello, Algebra 2 students. We're going to start 2-1 relations and functions. The learning target, we can analyze relations and functions and use equations of relations and functions. So in this video, you're going to have a lot of vocab, so bear with me. If you need to take a break, feel free to do so. So what is a function? That's what we're going to start out with. And you probably heard this before in Algebra 1. But a function is a relation in which each element of the domain is paired with exactly one element of the range. So when we are looking at that, we have to remember that the domain are our x values and the range is like our y values. Domain can also be independent variables and the range will be the dependent variables. And we'll talk about that more as the chapter goes on. But you have to know what a function is, meaning that one domain, one element of the domain is paired with exactly one element of the range. And I'll show you some examples on the next slide. So there's different ways to write a function. We can do it with a table, a graph, and a mapping. And notice that we have exactly one element of the domain is paired with exactly one element of the range, or with one element of the range. This one would not be a function, if you notice here, because our x's repeat. So this would not be a function. This graph would be a function because for every x value, there's one y value. So this is a function. And every domain is paired with a range. It doesn't repeat. 0 goes to 6, -2 goes to -3, 3 goes to 6, and 4 goes to 9. We don't see any repetition in our domain. So this is also a function. So there's two types of functions that we need to look at. The first one is one-to-one. So you might want to pause the video and write this down. One-to-one is exactly how it seems. One element of the domain pairs to exactly one unique element of the range, meaning the domain is not sharing any of the range. So exactly one element of the domain goes to the range. So no sharing. On to each element of the range corresponds to an element of the domain. So if you look here, the range, no one is left out in the range. So that is what onto, or that's how I think of onto. Each element of the range corresponds to an element of the domain. So no one's left out. And again, feel free to pause the video to write this down. Now there is a chance where the function could be both one-to-one and onto. Each element of the domain is paired to exactly one element of the range, and each element of the range corresponds to a unique element of the domain. So notice no sharing going on, and every element of the range is taken by the domain. Sorry about that. I had a phone call. Okay, so where were we? So there is a chance where it could be both. Okay, so the domain doesn't share anything with the range or with any others, and it's one-to-one, and the range is all used up. So state the domain and range of each relation, then determine whether each relation is a function. If it is a function, determine if it's one-to-one, onto, both, or neither. So I'll do the first one with you. This is a function here. And how we list the domain is we write a D and then our little brackets. And we're going to list all the x values that are used. So for example, -3 is used, -2, -1, 0, 1, and it looks like 3 and 4. And then we close off our bracket. Ooh, I'm having trouble here. Okay. And then we list the range. We do the same thing with the range. So it's 0 to, oh, excuse me, I wrote the wrong one. Look at my wrong notes. So it's -3, -2, 1, and 2 are the y's that are used. So you look across here to see what y's are used. And so is this a function? Well, this is not a function because of here. If you notice, the -2, it is paired with a +1 and a -2. So this is not a function. The domains can only go to one y, only one range, so that is not a function. I want you to go ahead and pause the video and try this one. Okay, so here's our domain. It doesn't repeat. Here's our range. Even though -1 goes to 6 and +1 goes to 6, we just list 6 once. And it is a function because our domain does not repeat. However, is it 1 to 1? Well, look at here. A -1 and 1 are shared. They share the 6, so it's not 1 to 1, unfortunately. And is it on 2? Well, if we look, 8 is not being used, so it's neither one of those. But it is a function. You can have that. All right, more vocabulary up next. A relation in which the domain is a set of individual points is said to be a discrete function. So this is what a discrete function looks like. This is a discrete function, so a set of points. Pause the video and write this definition down. All right, and then when the domain has a finite, infinite number of elements, and the relation can be graphed as a line or a smooth curve, the relation is a continuous relation. So this would be a continuous relation. Line or smooth curve. So the next part is, our next objective is to evaluate functions. This is function notation. This is called f of x. And this is just to show, instead of using y, it's just to show what we're plugging in for x. So for example, if we want to find f of -5, we would plug in -5 for x and evaluate. So f of -5 is going to be a -15 plus 2. Our answer is a -13. And then we plug in here. We're plugging in 2y for x. So we have f of 2y equals 3 times 2y plus 2. So f of 2y ends up being, when we slim this down a little bit, it's going to be 6y plus 2. That would be our answer. So we have a lot in this video, in this lesson, and the rest of it I'm going to leave up to you. Vertical line test. You probably heard it before in algebra. If you haven't, I want you to go ahead and research it. Maybe find a YouTube video to explain it to you, or if you want to look in the book, feel free to do it. But this is a way to tell if something's a function or not, and I want you to tell me how to work this. Okay, so that's what I have for you for next class, and we will see you in class when I see you. All right, have a wonderful, wonderful evening, day, morning, whenever you're watching this, and come with any questions that you may have. All right, adios.